So we did a little bit of this yesterday, and I'll show you some more examples today. Let's start with a pretty hard example right off the bat. So this is going to be the integral of dx over x squared times the square root of 1 plus x squared. Okay, it's a pretty bad looking integral. So how can we approach this? Well, the square root is the ugliest part of the integral, I think. And what we should try to do is write this square root in some nicer way. That is, figure out a way to write 1 plus x squared as a square. And that will get rid of the square root. So there is an example of a way to write 1 plus something squared in a different way. And it's right up there. Secant squared is 1 plus tangent squared. So I want to use that idea. And when I see this form, that suggests that we make a trig substitution and write x as the tangent of some new variable, which you might as well call theta, because it's like an angle. Then 1 plus x squared is the secant squared, according to that trig identity. And so the square root of 1 plus x squared is the secant of theta. Right? So that's the reason, this identity is the reason that this substitution is going to help us, because it gets rid of the square root and replaces it by some other trig function. I'd better be able to get rid of the dx too. That's part of the substitution process. But we can do that because I know what the derivative of the tangent is. It's secant squared. So dx d theta is secant squared theta. So dx is secant squared theta times d theta. So let's just substitute all that stuff in and rewrite the entire integral in terms of our new variable theta. So dx is in the numerator. That's secant squared theta d theta. And then the denominator, well, it has an x squared. That's tangent squared theta. And then there's this square root, and we know what that is in terms of theta. It's secant of theta. Okay, now we've done the trig substitution. I've gotten rid of the square root. I've got everything in terms of trig functions of a new variable. Pretty complicated trig function. This often happens. You wind up with a complete scattering of different trig functions in the numerator and denominator and everything. A systematic thing to do here is to put everything in terms of sines and cosines. Unless you can see right away how it's going to simplify, a systematic thing to do is to rewrite in terms of sines and cosines. So let's do that. So let's see. The secant squared, secant is 1 over cosine. So I'm going to put a cosine squared in the denominator. Oh, I guess the first thing I can do is cancel. Let's do that. That's clever. You were all thinking that too. Cancel those. So now I just get 1 cosine in the denominator from the secant there in the numerator. It's still pretty complicated, secant over tangent squared, who knows? Well, we'll find out, because the tangent is sine over cosine, so I should put a sine squared where the tangent was and a cosine squared up there. And I still have d theta. And now you see some more cancellation occurs. That's the virtue of writing things out in this way. So now the square here cancels with this cosine. And I'm left with cosine theta d theta divided by sine squared theta. That's a little simpler. And it puts me in a position to use the same idea I just used. I see the sine here. I might look around in this integral to see if its derivative occurs anywhere. The differential of the sine is the cosine. And so I'm very much inclined to make another substitution, say u, a direct substitution this time, and say u is the cosine of theta, because then du, oh, I'm sorry, say u is the sine of theta, because then du is cosine of theta d theta. And then this integral becomes, well, the numerator just is du. The denominator is u squared. And I think we can break out the champagne because we can integrate that one, finally, get rid of the integral sign. Yes, sir?
How do you know to make u sine rather than cosine? I suppose when you're doing...
Okay, how do I know to make u equal to sine rather than cosine? Because I want to see du appear up here. If I'd had a sine up here, that would be a signal to me that maybe I should say let u be the cosine. Okay? Also, because this thing in the denominator is something I want to get rid of. It's in the denominator, so I'll get rid of it by wishful thinking and just call it something else. And it works pretty well in this case. Wishful thinking doesn't always work so well, but... So I integrate u to the minus 2 du, and I get minus 1 over u plus a constant, and I'm done with the calculus part of this problem. I've done the integral now, gotten rid of the integral sign.